questions. So without much further ado, why don't we get stuck in straight away? And what I'm going to do today is I'm going to speak more about the actuators. Now, the purpose of an actuator is to drive the valve plug or the rotary trim element to a position that is required and to provide default positioning when no drive power is available. What does all of that say? Well, we need to have something to operate the valve, and it's going to be the actuator that we have selected that is going to operate the valve. Make sure it goes to 20% or 30% or 83%. We also need to have a fail-safe action in the cases where we lose the power that the valve is going to go back to its normal point of rest. Whether it be fail open or whether it be fail closed doesn't make a difference at all. So what is the purpose of the actuator? Well, it's there to give us continuous valve operations. We might use it if we're doing sequential control. It's there to make the operations a lot easier. If you happen to be operating in hazardous areas, you would go for an actuator. If you want to reduce the operating costs, you're going to consider an actuator. And as we have already said, there's going to be the opportunity of a fail-safe position that we actually can encounter. You're going to get different types of actuators. Possibly up until now, the most popular actuator in the world has been the pneumatic actuator, and we're going to find that there's various reasons for actually using pneumatic actuators. Firstly, they're the most popular that we can get. An advantage is that they're inexpensive, they're easy to maintain. We can adjust the speed if we need to. For example, we can change it from fast to slow. We can have a fail-safe action, air to close, spring to open, or air to open, spring to close. We can get very precise control, and it is good for explosive areas. Disadvantages would be that the pneumatic actuators would always require a clean source of air. Sometimes you want to have a hand wheel override, which can be expensive, and you're generally going to find that the pneumatic actuators, pneumatic meaning that it works with air, are going to be large, bulky, and extremely heavy. And if you don't believe me, have a look at the size of the valve that we are going to have. And remember all of the force that we need to overcome the force of that spring that you can see, that fail-safe action, that spring return. Remember the potential energy that I spoke about last week. You can just get an idea of the potential energy that is going to kick in over there. Right, I see a couple of people are battling with the connections, but the recording is going, so don't worry too much about that. We are going to get different types of pneumatic actuators. In the early days, when I was still a youngster learning in the field of instrumentation, we would have found that the diaphragm type was the most popular type of actuator that we got in our industry for various reasons. They were great for fine control. They did have a reduced stroke length. In other words, that arm that you could see over there wouldn't move all that much. They had relatively low thrust, and they were maintenance prone. They were bulky. They could not operate at higher pressures, and field reversal was not always possible. In other words, changing from an air to open to an air to close. But nonetheless, they were great valves that could be used. We would generally operate them with a signal of 20 to 100 kilopascals. We would get very rough control, or you could have put a valve positioner onto them if you wanted to. Precise control without a valve positioner was not possible, but with the valve positioner it most certainly was. Variations that you can get with the pneumatic actuators, as you can see, there's my diaphragm actuator at the top right hand side, and nowadays a lot of people are going to go more for the piston type of actuator, which is usually rated for 10 bar, although it operates probably between about 5 to 8 bar. As you can see, it is much smaller, and I can indeed tell you that the maintenance is cheaper and is easier, although it does not like to have dirty air. You can still get away with a little bit of dirty air on the top right-hand side, because if you do have any buildup of dirty air, it just goes and lies on the top of the diaphragm, and not too much is going to happen. You have dirty air at the bottom left-hand side, and you are going to find that the little O-rings are going to get damaged. The actuator is going to stop working very, very rapidly. Now, there's various types of pneumatic actuators that you can get, and you just have to have a look at what is going to be the right one for your application. You know, going back to my earlier years, I think in terms of something such as the double crank actuator, which would provide us with a high running torque, a very low backlash, and was good for modulating control, and that's actually what it looks like over there. Or you could have gone for what we refer to as the Scotch yoke, which was good for on-off control and gave us a very large torque, on-off control being fully open or fully closed, and that's the animal in question that you can see over there. Quite a large beast, but we used to use them extensively. Of course, linear actuators aren't the only pneumatic actuators that we can get. There's no reason why you can't go for a rotary type of actuator, usually operating a ball valve or a butterfly valve or a rotary plug valve. You can have them as single acting, in other words, air to open, spring to close, or air to close, spring to open, or you can have them as double acting. Double acting means you need to give it air to open it up and you need to give it air to close it. If you lose your air supply, it's going to fail in the last position that it actually did have. So your valve is going to dictate what the actuator is really going to be. And just to refresh the memory of those of you who don't work with us every single day, the valve is the part that I've gone and marked out in purple, and the actuator is going to be the very large device that one can see at the top. And in this particular case over here, just as a matter of interest, what we've got is we've got an application where we've got plastic bodies. So you obviously know this is going to be a low pressure duty, and there's probably going to be some type of severe corrosion that is going to come into play. Now, sticking to the pneumatic actuators, one can get a variation. One could, of course, go for what we refer to as a rack and pinion type of actuator, which is very compact. It's very economical. It does have a little bit of backlash, and as a result of that, it is more often than not used for on-off operations. Although it can be used for control operations, you just need to go and put your valve positioner on, and the ones that I've used have always had the valve positioner that is fitted straight on at the top over there. It is inexpensive. It does have a size limitation. It's not ideal for modulating control, but you know, if you need to use it, you actually can get around and use the device. We're going to find that they give us a constant high torque. They have minimum hysteresis losses. The stroking speed is relatively high, and they are easy to put together, to assemble, to do the maintenance. You can see where the rack and pinion actually comes in on the inside, whereas that rotates, so we're going to get the actuator to open or close, and that's going to operate the valve that you would be with. I keep on stressing that it does not work very well with dirty air or moist air, and the reason is that those little O-rings that you can see that I've gone and marked out get damaged very, very easily, and so you have to just try and make sure that you are going to protect them at all times. Once again, just to show you the O-rings, they would be the blue and the green little areas that I have gone and marked out on the screen. Now, these aren't the only pneumatic actuators you can get. You can get something such as a rotary vane actuator, which is a good alternative to piston actuators, especially where high loads are going to be encountered. There are no links and gears. It is bulky and heavy. Maintenance problems do occur probably more frequently than you would like to have them, but it is something that one can actually have a look at. It's what we refer to as a quarter turn actuator. In other words, you can see the small amount of turn that we are going to get. You can get a fail-safe operation. This is really going to occur in a very limited range. Okay, that is the pneumatic actuators. What are the other choices that one could have a look at? Well, what about an electric actuator? An electric actuator does not require clean air or anything else. It just requires electricity. It's going to be used where other actuators are not practical. You're going to find that the technology is continuously improving. Have a look at how small they've become nowadays. Often they have got a hand wheel as well as limits as standards on these devices. Still pretty slow in certain applications. They don't always have a fail-safe action. They're not extremely good for modulating control. They can still be a bit expensive, and they most certainly are going to be difficult to maintain. You're also not going to consider using these devices in explosive areas because of the risk that you're going to run when you have got the elevated voltages that are going to be present. Right, so we've dealt with pneumatic, we've dealt with electric. The only thing that's left is going to be the hydraulic actuators. Hydraulic actuators will give us a fast action. They're very, very suitable for remote areas. They do have a fail-safe action, especially if you've got the accumulator that goes hand in hand with them. They're very small, they're powerful devices, they are quite expensive. Positioners aren't always readily available, and you're going to find that the maintenance is usually going to be much more difficult on these devices than would be the case on the pneumatic actuators. And of course, you need to send your working staff on very specialized training courses. Now, we've done pneumatic, we've done hydraulic, and we've done electric. Please don't remember that there is a fourth choice that you can have a look at, and this is going to be a manual actuator. In other words, you're going to do the hard work with your arms. This is a manual actuator and not a manual override. It is really just going to be the manual method that we are going to use for actuation. Now, ladies and gentlemen, I would like to just break very briefly, if I can, and do a bit of a practical with you. You're going to see that this is going to come in quite a couple of times during the course of today's presentation, but